Alright, so now we are moving on to multiplication of polynomials, and here's a typical Regents language word problem. When written in standard form, the product of 3 plus x and 2x minus 5 is. Now we know that we're dealing with now multiplying these two, not adding them, not subtracting them, but multiplying them because of the keyword being product. So for example, when it says 5 the product of 2 and 3, they're asking you to multiply 2 and 3. Notice that I actually use parentheses. This means to multiply. Parentheses, if you don't see any sign here like plus or minus or division, then there's an invisible multiplication sign between the two. So let's go ahead and set it up because it's a word problem and it needs to be set up. We're being asked to multiply these two. Now, just like the other two videos on adding and subtracting, I'm going to put the invisible exponent of 1 when you don't see one, and the invisible coefficient of positive 1 because of the plus sign in front when we don't see one. Now, before we go here, let's just take a quick reminder going back, way back from starting 4th grade, the product theorem. So when we are multiplying two of the same, then we add their exponents. So we have here x to the invisible 1 times x to the invisible 1. That means I have 2 x to the second power. We're adding the exponents. The exponent is telling you how many times to repeatedly multiply the base. X to the second power means I'm multiplying x to itself 2 times. For example, x to the 4th power means I am multiplying x to itself 4 times. 1x, 1x, plus 1x, plus 1x. So if I add, since I'm multiplying these, I add the exponents to give me that. And it makes sense why I'm adding, because this is telling me how many x's I'm multiplying to itself. So I'm adding the numbers and I'm multiplying to itself repeatedly to give me my simplified exponent. So for example, x to the second power times x to the 3rd power. That means I have 2 x's being multiplied times 3 x's being multiplied. So that's 2 plus 3, 5 x's being multiplied to themselves. Now what happens if you have a coefficient? A coefficient So when we multiply two terms, in here we do multiply the coefficients, the number in front. Negative 2 times 3 is negative 6. And then we add the exponents, assuming they have the same base. And both these terms, here the variables are the same. So I have 1x times 4x is being multiplied. 4 plus 1 is 5. So we add the exponents and we multiply the coefficients. Feel free to go back and stop. If you need to think about it, digest it before we move on. So keeping that in mind, here we are multiplying two polynomials. when we multiply, we distribute. The first polynomial has a 3. A 3 is being multiplied to the entire second polynomial. And that's why we can write it this way. 3 is being multiplied to the entire second polynomial. But we also have, in the first polynomial, we have the term of positive 1x. That term is also going to be multiplied to the entire second polynomial. Another way to kind of think about it was we decided to, let me just get rid of these arrows here. Write one polynomial vertically down. So 3 plus 1x. Here we have it 3 plus 1x here written vertical. Here it's written horizontal. And then we take the other polynomial that's being multiplied and we rewrite it next to the two terms from the first polynomial. So then we go ahead and we multiply the coefficient to the number 3. So 3 times 2, 6. 3 times 2, x ones. 3 times negative 5. There's no x here because there was no x next to the 3 or the 5. And then we do the same thing here in the second row here. 1 times 2. So we multiply the coefficient, so that's 2. And then we add the exponents of the variable because they're the same variable. So x to the first times x to the first is x to the second, 1 plus 1. Notice I didn't forget to draw in the invisible the invisible exponent of 1. And then we have 1 times negative 5. It's negative 5. But I'm not going to forget to put the x because we have 1x times negative 5. There's nothing to add because the negative 5 doesn't have a variable or a variable x to add the exponent. So, but the x doesn't go away. Okay. Now, because I did it this way, notice that my original first polynomial, it wasn't in standard form. The 1x should be listed before the constant. The constant should always be the last number in an expression. It kind of caused this to go a little bit off. So what I'm going to do is I'm going to shift these two terms over this way because they're not like terms. Notice that if you look at the first column, these are not like terms. They do have the same variable, but they don't have the same exponent. This 6x should be on top of the negative 5x because those two are like terms. Same variable, same exponent. So I'm going to move over the negative 15 and then I'm going to move over the 6 to the 1. So now they're lined up by like terms. Once we're here, we multiply across so then we can add and combine any terms that are like terms. Notice that there are no other 2x squared terms, which is why I shifted everything over on the top, so I just have 2x squared. But now I can add these two x terms, so I can figure out how many x to the first do I have. I have 6 here, take away 5, gives me 1x to the first. And then there's nothing to combine with the negative 15. And the final answer in a multiple choice in the regions, you're not going to have the invisible 1 there or the invisible 1 there. This method is actually much more clear to see when we are multiplying a binomial with a trinomial. So let's do that. We have here another problem. We have 2x plus 3. Notice this one is written in standard form because the x terms come before the constant. And now we are going to multiply a trinomial, 4x squared minus 5x plus 6 to the binomial here. That's a square, by the way, a 2. Let's make that a little bit clearer. There. And then I'm going to put the invisible 1 there. Okay. So it says find the product. That means I'm going to multiply. So I'm going to just put the parentheses right next to each other. I'm not going to put any symbol like addition or subtraction because product. So there's an invisible multiplication next to the parenthesis sets. That's how I set it up. It's two polynomials being multiplied to each other. So I'm going to go ahead and set it up to pick one polynomial. I'm going to pick the shorter one, and I'm going to rewrite that one going vertically down. 2x plus 3, 2x plus 3. So rewrite it going down. And then we're going to take the longer polynomial, the trinomial, with the one with 3 terms, and I'm going to write it right next to, I'm going to put the invisible 1 there, each of the terms going down. It's going to be next to the 2x and next to the plus 3. If this had been a minus 3, I'd bring down the minus from minus 3. Okay? So one polynomial gets rewritten going vertically, and the other one gets rewritten multiple times next to the terms going vertically. And then we're going to distribute. So first we're going to distribute the 2x to the entire second polynomial. You're going to multiply the coefficients. 2 times 4 is 8. And then we're going to add the exponents. 1 plus 2 is 3. So that's this first arrow. Then I'm going to do the second distribution. 2x times negative 5x. 2 times negative 5 is negative 10. And then we have x is 1 plus 1 is 2. So I added the exponents. 2 times 6, positive 2 times positive 6 is 12. Now I don't want to forget the x because the x is there. Okay? It's not 2 times 6, it's 2x times 6. And there's nothing to add to that exponent because the 6 is by itself. And then I'm going to do now I'm done here. I'm going to do now the second row here. 3 times 4 is 12. I'm going to put it underneath the second column because it's 3 times 4x to the second power. There's no x here to add to this exponent here. Then we have 3 times negative 5x, that's negative 15x. The x is still there. And then positive 3 times positive 6 is 18. And then they're like terms. There are no other x to the third term, so bring down the 8x to the third. Then to figure out how many x to the second I have, I'm going to add down. Negative 10 plus 12 is 2. And it's a positive 2, so plus. Then I want to know how many x terms I have. I have positive 12 plus negative 15 is negative 3. And nothing to add to the 18. And I'm done. Hopefully the color coordination does help a bit in how we multiply a binomial with a trinomial. It's the same format if you were multiplying two binomials. So two terms of the same number, two polynomials, each of them having two terms, would follow the same format. Thanks, take care.